In this video, we're going to go through all of the ways that you can factor. If you want to see the whole video, you can watch from beginning to end, or you can jump to the slide that you needed. Slide 2 is GCF. Slides 3 through 5 is factoring trinomials when the coefficient of x squared is 1. Slides 6 and 7 is when the coefficient of x squared is not 1. Slides 8 through 10 are differences of two squares and perfect square trinomials. Slides 11 and 12 are four-term polynomials, and slides 13 through 17 talk about how to solve any of these type of polynomials equations by factoring. To factor using the GCF, you look at each term and try to find the largest number or variables that each has in common. So from 3x squared and 12x, there's a common factor of 3x. So you take out a 3x, you're essentially undistributing, and inside the parentheses you put what would remain if you divide, because when you distribute you multiply, so if you divide by 3x. So here you'd be left with x minus 4. This entire thing is your answer, and you can check your answer by actually distributing, and you'd get 3x squared minus 12x. So that's how you know that that's right. On this next one, negative 8 and 10 have a common factor of 2, but I also want to take out a negative 2 to make this positive. And then you can also take out an xy as well. And then you'd be left with 4x plus 5. And again, you can check your answer by distributing. So negative 2xy times 4x would be negative 8x squared y minus 10xy. To factor trinomials, which means three pieces, when the coefficient of x squared is 1, all you need to do, you're essentially unfoiling. So you're coming up with the two binomials that if you were to FOIL these would get you x squared plus 9x equals 20. These two missing numbers first have to multiply to get c, which in this case is 20. So we have some options: 20 and 1, 10 and 2, 5 and 4, and that's it for 20. So of these pairs, you choose the pair that also adds to b, which in this case is 9. So that's going to be 5 and 4. So the final answer is x plus 5 times x plus 4. If you wanted to check this answer, you would FOIL. So x times x is x squared. If you do outer and inner, you get 4x plus 5x, which is 9x, and then last, 5 times 4 is 20. In the next problem, we're looking for two numbers that multiply to get 12, but add to negative 8. So if you're multiplying to get a positive, but adding to a negative, then you know that both numbers must be negative. So one way to start is by listing the factors of 12, which would be negative 12 and negative 1, negative 4 and negative 3, negative 6 and negative 2. And then because they need to add to negative 8, the option would be negative 6 and negative 2. And again, you can check by FOILing. So similar kind of problems, we're still looking for the factors of c first, and then they need to add up to b. Now in this case, because c is a negative number, then that means that one of them is going to be positive and one of them is going to be negative, which gives you a lot more combinations. So for negative 18, it could be negative 9 and 2, but then it could be 9 and negative 2, 18 and negative 1, negative 18 and 1, 6 and negative 3, or negative 6 and positive 3. So now these are all the possibilities that can multiply to get negative 18, but now I'm looking for the ones that add up to negative 7. So that would be negative 9 and 2. So final answer of x minus 9 and x plus 2. And again, if you FOIL, you get back this trinomial. On this one, you have factors of negative 30 that add to positive 1. So that would be positive 6 and negative 5. You should be able to see that if you were to reverse these, if you had said negative 6 and positive 5, those would add to negative 1. So always check that they're multiplying first to get c. 6 times negative 5 is negative 30. 6 plus negative 5 is 1. And then add to get b. On a problem like this, here the coefficient of x isn't 1. Right now it's negative 1. So to start, you're going to undistribute or factor out a GCF of negative 1. By doing that, what's going to happen is the trinomial becomes x squared minus 17x plus 72. So by taking out a GCF of negative 1, you change the coefficient of x squared to 1, which is what you want. So then you keep the negative 1 outside, and now you factor just the pink part by finding the factors of 72 that add to negative 17. And those two factors would be negative 8 and negative 9. So your final answer is negative 1 times x minus 8 times x minus 9. So at this point, things change because the coefficient of x squared isn't 1 anymore. And there's no GCF. It's not like everything is divisible by 2. So the way that you start this is that you open up your parentheses with, in this case, the only combination that can work to get 2x squared is 2x times x. Then we're looking for numbers to go in these two slots. And two things have to happen. The first thing is, whatever numbers go here have to multiply each other and get 7. That's not too hard. That's got to be a 7 and a 1. What's tough is that, depending on which digit you put here, if you do outer and FOIL, you're going to be multiplying that by 2. So if you put the 7 here, you're going to have 7 times 2. If you put the 1 here, you're going to put 1 times 2. And then whichever digit goes here, its partner has to go on this line, which is the inner in the FOIL, which really gets multiplied by technically a 1. And then when you add the answer from inner plus outer, you have to get your middle. So in this case, I want to put the 1 here and the 7 here. Everything's positive, so it's plus everywhere, which is nice. 2x times 1 is 2x. 7 times 1 is 7x. And 2x plus 7x is 9x. So you would check by FOILing, which is really important. 2x times x is 2x squared. 7 times 1 is 7. 2x plus 7x is 9x. On this kind of a problem, it's a little bit harder because that's not prime. So you could have parentheses opening with 6x and 1x, or they could open with 3x and 2x. What can be a little bit easier, though, is that these two numbers have to multiply to get 2. And the only two numbers that will do that are 2 and 1. Now what you have to remember is that if this is a 2, it's 2 times 6. If this is a 1, it's 1 times 6. So I could actually go through all the combinations. I could try 2 and 1, which would give me 6x squared, 2, and then 12x plus x would be 13x. That doesn't work. So I could cross that out, and I could just switch them, which would be 1 and 2. And then I could try, I still know I get 6x squared and 2, and then I would get 6x plus 2x, which is 8x. So that doesn't work. So I know that's not my answer. On the bottom, now I can try that with the 3x and the 2x. I'm still dealing with 2 and 1. So I can already see if I put a 2 here, 2 times 3 is already the 6 that I need, and then I'm going to have too much. So I'm going to try it with the 1, and which means this has to be a 2. So then I get 3x times 2x is 6x squared. 2 times 1 is 2. And then outer plus inner would give me 3x plus 4x, which is 7x. Again, everything's positive, so it's nice and easy. So I just do pluses, and that's your final answer. Checking the outer and the inner is the most important part of these types of problems. They have to add up to your middle term. So on this next example, it's pretty easy because the only way to get 2x squared is to have 2x and x. Where it gets a little harder is that these two digits have to multiply each other to get 6. So that could be maybe 6 and 1. Those would partner together, either 6 and 1 or 1 and 6. Or it could be 3 and 2, which could mean either 3 and 2 or 2 and 3. Remember that whatever goes here is going to get multiplied by 2. My goal is to eventually do outer plus inner and get negative 13. So I actually want this to be my 6 because 6 times 2 is 12, which is getting me pretty close. And then if this is a 6, this has to be a 1 because 6 times 1 is 6. So then I would get 12x, 1x. The last part I have to consider is I need it to add to a negative but multiply to a positive. So that means that they both need to be negative. That's my answer. And you always check. 2x times x is 2x squared. Negative 1 times negative 6 is positive 6. Negative 12 plus negative 1 is negative 13. On this one, again, open with 2x and x. These two numbers here need to multiply to get negative 7. I'll worry about the sign later. I just want to think about the digits, which have to be 7 and 1. Whatever digit I put here is going to get multiplied by 2. So I can see that if that were a 7, that'll get me to 14, which isn't bad. It seems like it might get us somewhere. And if that's a 7, that's got to be a 1. So then 14x from outer and 1x from inner can combine to get 13x if this one is negative. So if I can make 1x negative and 14x positive, I'm good. And to do that, that would be minus 1 plus 7. And again, you check. 2x times x is 2x squared. Negative 1 times 7 is negative 7. 14x minus 1x is 13x. Here I have a binomial, and there's no GCF. 4 and 9 don't have anything in common, and this doesn't have any x's. But what I do notice is that because it's subtraction, it's the difference of two squares. This is a perfect square, and this is a perfect square, which follows the formula. The difference of two squares, a squared minus b squared, came from a plus b times a minus b. So if 4x squared is a squared, a must be 2x. And if 9 is b squared, b must be 3. So I can just plug it in. 2x plus 3 times 2x minus 3. It's important to recognize difference of two squares because there's no other way to factor it other than using this formula down here. I could factor this one by opening parentheses and trying different combinations like 9x and x or 3x and 3x. But instead of doing that, if you can recognize that it's a perfect square trinomial, it's a trinomial because it has 3 pieces, and it's perfect squares. It's a perfect square trinomial because these are perfect squares. The square root is 3, the square root is 2. 3 times 2 is 6, times 2 is 12. Then hopefully you can recognize that it came from this. It's in this form, which came from this formula, a minus b squared. So I can just set that up, and I would get 3x minus 2 squared. Now to check something like that, to remember to square something, it means to multiply by itself. You would do 3x minus 2 times its exact self, and then FOIL. And you would get 9x squared, positive 4, negative 6, plus negative 6 is negative 12. Had you factored this the traditional way, you just would have gotten 3x minus 2, or the guess and check method, you would have gotten this, which is fine, but you can see that 3x minus 2 is being multiplied by its exact self, which means it's being squared. So in this example, we have a trinomial, but it's not a perfect square trinomial because 3 and 48 definitely aren't perfect squares. But there is a common factor of 3, so I'll factor out the GCF, and you get x squared plus 8x plus 16. And now the perfect squares the ends are perfect squares. So it's in the form a squared plus 2ab plus b squared, because if b squared is 16, then b is 4. 4 times 2 is 8, and a is 1. So that means it comes from a plus b squared, which would be x plus 4 squared, and then the 3 that was out there just drops down. So in this example, the first thing I would notice is that there's a common factor of 2, and that when you factor out that GCF, you're left with 4 minus 9n squared. And 4 minus 9n squared is the difference of two squares. So that would become 2 plus 3n times 2 minus 3n. And the common factor of 2 that came out stays outside. This one over here, there's actually 2 ways to do. The first is, and what you should be looking to do all the time, is to take out a GCF. So the GCF is 4. And then you're left with y squared minus 16, which is the difference of two squares, so you can factor again into y plus 4 times y minus 4. Now this should be the final answer. Sometimes what happens is people look at this first and they say it's the difference of two squares, because 4 and 64 are perfect squares, which is true, so you can actually factor it into 2y plus 8 times 2y minus 8. Now the problem with that is it's not completely simplified, because 2 and 8 have a common factor of 2, which leaves you with y plus 4. But then 2y minus 8 also has a common factor of 2. I'm going to pull out another 2, which leaves you with y minus 4. But these two 2's multiply each other to get that 4. So you get the same answer, but you might be less likely to take out the GCF if you don't do it first. It's the same idea of if you have 10 over 20 and you reduce it to 5 over 10, 5 over 10 is a simplified version, but the simplest version that you need is 1/2. Same idea here. 2y plus 8 times 2y minus 8 is a factored version of this, but it's not the most factored because you have to take out a GCF of 2 and a GCF of 2, which really means you had a GCF of 4. So the final answer should be completely factored, which is 4 times y plus 4 times y minus 4. In this type of example, because it's a 4-term polynomial and not everything can be divided, there's no GCF, not everything has an x and not everything has a 3 or a 5, you start by making 2 groups, and then you look at each group separately. So the GCF of x cubed plus 3x squared would be x squared, and then you're left with x plus 3. Bring down your plus sign. And the GCF of 5x plus 15 is 5. And then you're left with x plus 3. So now, I'm actually just going to change the color of this. If you look at the white and the pink, they have something in common. They share an x plus 3. So that becomes your GCF this time, which you pull out and put in front. And if you take the x plus 3 away from here, you're left with x squared. And if you take the x plus 3 away from here, you're left with plus 5. And that's just like up here when you took out the x squared from x cubed, you're left with x, and when you take it out of here, you're left with 3. So this would be your final answer. On this type of example, we're going to factor by grouping, and the GCF of the first group is x squared, which leaves you with x squared minus 1, and the GCF of the second group is 3, which leaves you with x squared minus 1. Just something to consider, before you make your 2 groups, it always needs to be a plus sign. So if this was a minus, before you put in your parentheses, you would make it plus negative and then group. So now we have a common factor of x squared minus 1, which leaves x squared plus 3. But you can factor one more time because x squared minus 1 is the difference of squares. So it becomes x plus 1 times x minus 1, and then x squared plus 3 just stays. And that's your final answer. Most people forget to see that this can be factored again, so be careful to be on the lookout for difference of squares. In this example, you're trying to solve for x. You can think of them as solutions or roots, which are values of the equation, values of x that will make the equation equal 0. So in order to solve, the first thing that you have to do is make the equation equal 0. So to do that, I'm going to minus 15x from both sides. And now that it equals 0, I'm ready to factor. You're not ready to factor ever until it equals 0. The GCF of 6x squared minus 15x will be 3x, which leaves you with 2x minus 5 equals 0. So now because you're multiplying 3x by 2x minus 5 and getting 0, that either means that 3x equals 0 or 2x minus 5 equals 0. So you can set up 2 separate equations. 3x equals 0 and 2x minus 5 equals 0. Because now if we can find the values of x that would make these equal 0, we have our roots. Here, to isolate x, you just divide both sides by 3. So x equals 0 is one solution or root. And here you solve using reverse PEMDAS, and you get x equals 5 over 2, which is our other solution or root. They're both answers, so you leave them both. If you go back to this problem right here and replace x with 0, you'd have 6 times 0 minus 15 times 0, which is 0, so that checks out. And if you also replace x with 5 over 2, you would get 0. Or you could plug them back in here and you'd get a true statement. So this example, because it's solving, should say equals 0. So we'll just add that in. And then, because it equals 0, I'm ready to factor, which means I'm looking for the factors of negative 18 that add to 3, which are 6 and negative 3. And then if I can get one of these two quantities, or both, to equal 0, I found my roots. So x could equal -6 or +3. Those are the solutions or roots. On this example, you're not ready to solve yet because it doesn't equal 0. So to make it equal 0, you'd subtract 24. And now you're ready to factor by finding the factors of -24 that add to -2, which are -6 and 4. And so then the two roots or solutions would be x equals 6 and x equals -4. This example already equals 0, so we're ready to factor. And this time a isn't 1, so we know it's going to open with 2x and x. So then we're searching for two numbers that can multiply to get -63. But then when you do outer and inner, would add to +5. So if I put a 7 here, then 2 times 7 is 14. If this is a 7, 7 times 9 is 63. And 9 times 1 is 9, so I have 9x and 14x. And if I make this one negative, they'll add to the +5, so -9 plus 7. And so now I'm ready to solve. So 2x minus 9 could equal 0. If you add 9 and divide by 2, you get x equals 9 over 2, or x plus 7 could equal 0, and x equals -7. So in this example, we're still solving by factoring, so you need to make it equal 0 by subtracting 49. And then because it's the difference of two squares, it would factor into x plus 7 times x minus 7 equals 0, making the two solutions x equals -7 and 7. Eventually we'll learn another way to factor this, or to solve this, one of which will be square roots. But this is how you solve by factoring.